Hi all, my name is Brijesh Singh and welcome back to my channel. So why many natural phenomena from height of individual to the exam score tends to follow a particular patterns. So today we are going to uncover this natural phenomena which is highly used in statistic, which is called as a normal distributions. The normal distribution often called as a bell curve. It is a fundamental concept in the statistics. It is a continuous probability distributions that describe how data is distributed. And you expect more values lies in between the middle of this curve. So there are few examples we can take: height of group of women and IQs of the group of women and the weight of the cold drink bottles. So these are the example which follows the normal distributions. So if you observe the distribution, it's mainly symmetric around the mean, median and the mode, right, which is also coincidentally center of this curve. So there are many interesting characteristics of about this normal distributions. So for example, so if you say mu equal to mean, so we will denote mu to mean and standard deviations eta as a standard deviations. So the probability of this value is lying between this mu and standard deviation. So all the probability values lying between these mu's and standard deviations. So what are the characteristics we can draw from here? So let's say this is the curve and center is around the mean. So you can say that, so these are the standard deviations. So if we go mu minus theta 1 and then mu minus 2 theta and mu minus 3 eta, right? Similarly, if we go from left side, mu, so this is positive, and mu minus eta, mu minus 2 eta and mu minus 3 eta. So the difference, if you see, these are the, if you go from mu minus eta to mu plus eta, you will get a 68% of the value has been, probability value has been distributed. So similarly, if you go to mu minus 2 eta to mu plus 2 eta, so you will find 95% of the distributions lies in this range of the standard deviations. And if you go further and identify the mu minus 3 eta and mu plus 3 eta, so this will be lying around 99.7%. So this is also called a 1, 2, 3 rule of normal distributions. Now, if you see, we have introduced 4 major jargons, right? First is mean, median, mode, and the standard deviation. Let's try to understand with some examples. So let's say if you have an array of few numbers, right, 4, 5, 3, 9 and 14. So the length of this is 10, right? And so what would be the mean here? Mean, which we denotes with the mu. So what would be the mean? So mean is a summation of n divided by capital N. So what is n here? So n is a number of individual value, and capital N is length of the array, right? So if you want to find the mu from these equations, So what you will get of 4 plus 5 plus 3 and so on plus 14, right, divided by 10. So if you just calculate all these, just addition all this summation, you just do the summation of all these. So you will get 109 by 10, which we can divide and say 10.9. So what would be the mean here? Mean would be 10.9. So mean we also refer as a average of the numbers. Now if I say what would be the median? So in order to understand the median, first we have to identify whether the length is even or odd. So if it is an even number of the length of the array, so in this case we have an even number. So so the formula for this median you can calculate by n by 2 plus n by 2 plus 1th element, nth element divided by 2. So if you see the n by 2th of element is basically, so we have a 10 digit here. So nth element, n by 2 is you have to find out to the at 5th positions, 5th index we have to find 1 2 3 4 5. So 20 by 2 and 20 by 2 plus 1, right? So 20 by 2 plus 20 by 2 plus 1 divided by 2. So 10 plus 11 0.5 somewhere here. No, 11 only, right? 11 by 2. So you will get a 10.5 as a median value, right? So the median value will come 10.5. And mode, if you want to calculate the mode, so mode is basically a most common value from the population data sets. So let's say you have this is a data sets, right, with the 10 elements. So most common values which is occur. So if you observe here, there is nothing common, right? So all digits are unique. So we can say that mode, there is no mode in this data set, right? So but if you have like 5 has repeated multiple times, so you can say the mode is 5. But in this case, all the array data sets has a unique value. There's no value frequency, right? So all value frequency is 1. So in that case, we don't have a mode in it, right? So and then, so these are the very important concepts. Mean, median, mode is very important concept because when we talk about the EDA concept, right, exploratory data analysis, there is a concept called data cleaning, right? So in the data cleaning, sometimes we used to impute a data. Imputation of the data means, let's say you have a null values, or you have the values which is not coming in that particular column. So there are few columns which is a blank or maybe a empty values, right? So you want to impute some value. So what you can do, you can use these mean, median, mode. So I mean it depends on what type of imputation you are doing, right? So you can also replace if the majority of the values are commonly, right? So value frequency is very high of particular value, so you can easily impute that value with the mode. But sometimes we do imputation with the average, sometimes we do imputation with the median, right? So it depends on the data sets. So that we can obviously talk about when we are going to cover the EDA sections. But for now, you can just refer this as a very interesting topics, because this can be utilized in a lot of various format, right? Now let's talk about the standard deviation. So in statistics, the standard deviation is measured the amount of variation in the dataset values, right? So it measures the amount of variation in the datasets. The low standard deviations indicate that your datasets is around the mean, right? So it's highly distributed around the mean. So if you have a low standard deviation in your data sets, which means most of the value is around nearly around the mean. So in a high standard deviation, your value is basically distributed in the width in the range, right? So your bell curve would be wider in that case. So if we denote standard deviations with eta, then we can say summation of x of I minus mu the whole square divided by capital N. So if I simplify each and every elements here, so eta is a standard deviations, x of I is a individual x, x of I is basically each value from the populations, value from the population, and mu is a mean or average of population, and capital N is a size of the population, number of element in population. Right? So N is basically denoting a length of the populations. So now take some example, right? Try to understand what it reference basically. Now, if I say to you, if you have a mu equal to 35 and standard deviation is 5, and if I say find the probability of normal random variables x, find the probability of this normal variable x, which lies between 25 less than of x less than of 45, right? So this is the question, right? So we have so we need to find the probability of x, a random variable x lies between 25 to 45, right? Now if you just observe that, right, so how we can write this 25 is mu minus 2 standard deviations, right, less than x less than 45 is mu plus 2 standard deviations, right? So mu minus 2 standard deviation and mu plus 2 standard deviation, what we have, 5 into 2 10, so in 35 minus 10 we will get the 25. So similarly, right, so we can clearly see the mu minus 2 standard deviation is of 25, mu plus 2 standard deviation is at 45, right? Now just go to the graph which we have shown. If our range of the probability between my mu minus 2 standard deviations from to mu plus 2 standard deviation, what we will get a 95% of the probability. So we can easily conclude this, the probability of this problem is 95%. So it lies between from mu minus 2 standard deviations to mu plus 2 standard deviations, which comes around the 95%. Let's take a different example. So as soon as you go with the more and more example, you will get a more understanding around this, right? Just find out the probability for 25 less than equal to x less than equal to 50. Right? What would be this? So in this case, we can denote this as a mu minus 2 standard deviation, and this we can denote a mu plus 3 standard deviations, right? And mu plus 2 standard deviation and mu plus 3 standard deviation. So this will gives us a if we divide this will gives us a 49.8%, and if this will gives us a 47.5%. So we can just calculate this. We just have to add and we will get a 97.35%. Okay, so mu plus 3 standard deviation, we will get a 99.7. So half of the value, because we are only taking mu plus 3 standard deviation, right? So mu plus 3, from mu to mu plus 3 standard deviation is basically a 99.7 divided by 2, right? So we will get 49.8. Similarly, for the mu minus 2 standard deviation, we will get around 95%. So we divided 95 by 2, we will get a 97.5. And then when we add these two numbers, we will get a final probability of this variables. Similarly, so let's find out P example 3, right? So probability where x is less than 40, right? So less than 40, right? So what we will saying here, so this will belongs mu plus sigma. So mu plus sigma, right? So if you observe here, from mu minus sigma to 1 mu plus sigma, we have a 68% of probability distributions. So, and when we divide this 68, right, 68, so mu, from mu to mu plus sigma, so this will give you a 68 divided by 2 equal to 34%, and then mu is 50, right? So 50 plus 34, you will get 84%. So probability of this is 84%. Now so far we understand what is normal distributions. Now it's time to understand the what is standard normal distribution, which is also called a z-scores, right? So in general, we are interesting to find how many standard deviations, from mean our random variable x are, right? So whether it's a mu minus sigma or mu plus sigma, right? So these kind of general formation we used to get, right? So if I say to you, for example, if you have just take example, mu equal to 35, same example, right? Standard deviation is 5. Now if I say x is 43.25, right? So if I say how far this 43.25 from 35, right? So you got a one random variable x which values has a 43.25. Now you have to find out how far this 43.25 from the mean values, right? So if you draw this, so if you see, you have mean here, which is here, and which is 35, right? And then you have 43.25. So let's say 43.25 you will get here, mu plus some random variable x, some eta which unknown, right? 43.525. So what is the difference between these two? So you will get a 8.25, right? So this difference is 8.25. Now if you divide this 8.25, so our standard deviation, what it says, so our standard deviation, it says how far you are from the mean, right? So we can also refer this as standard deviation. This much of standard deviation we are far from this mean. So 8.25 divided by 5, right? We can get a 1.6 standard deviations. So we can also say mu plus 1.6 standard deviations away we are from the mean. This value 1.6 standard deviation is called a Z score. So this is 1.6 eta is actually a Z score for of given random variable. Now also you can denote this Z equal to x minus mu, right? X is the value of the random variables minus mu divided by eta. So you will get a Z score from this equation. Similarly, we have done the same, right? So we have identified the difference. Difference was 8.25 and then divided by the eta. So we will get a Z score of these random variables. Okay. Similarly, if you see probability of -2 less than Z less than +2, right, in the form of the same thing, right, which we have done for the normal distribution, same thing we are doing with the Z score, right? So if you see, this is equivalent to the probability of mu minus 2 eta less than x less than mu plus 2 eta, right? This is all same. Similarly, for p minus 3 z plus 3, we will get p mu plus 3 eta less than x of mu plus 3 eta, right? Similarly, for the p equal to -1 z plus 1 eta less than x less than mu plus eta, right? And if you calculate this was coming 95%, and this was coming 97.35%, and the probability of this range would be lies between so this was 95% and then this was 68%, right? And this was around 99.7. 99.7. You can write again 99.7%, right? So now let's talk about the same example which we have given. So probability of -2 z minus 3, right? So this will comes like p of mu minus 2 sigma plus less than x less than mu plus 3 sigma, right? Which was we already calculated, right? Which comes around 97.35. Similarly, for the pz less than equal to 1, we have, right, pz less than equal to 1, which means 30 mu plus sigma, what we get 84%. Right? So same way, right? So if you see, this Z score is more informative as compared to the normal distributions, right? So now we can say this is mean, mu. So this is a Z chart, and this is a probability density, right? So if you see -1, -2 and -3, similarly +1, 2 and 3, right? So if you, as long as you go in the left side, right, you will get a low cumulative probability. And as long as you go on the positive direction, on the right side direction of your mean, you will get a high cumulative probability, right? So because we are talking in the continuous probability distributions, and the normal distributions comes in a continuous probability distribution, right? So if you calculate the cumulative range from left to right towards the mu, so you will get a low, and if you go further from mu to rightmost, so you will get a high cumulative probabilities in this range. You can also calculate here. So let's say, for example, you have a mu equal to 65 miles per hour, right? So there is some speed of the car. The average speed is 65 miles per hour. So, and random variable for x equal to 73. So you are running with 73 miles per hour, and standard deviation is 5. So right. So you are actually driving a car more than the speed of the average speed, right? So in that case, what would you will get the Z score. So Z score is 73.65 divided by 5. You will get a 1.60, right? So your cumulative probability will get increased in this case. So if you calculate this Z score, which 1.60, the cumulative probability will come of Z is around near about 94.53. I'll talk about how we can calculate this. And let's say you are driving below the 65 mile per hour, right? So you are driving with 60 mile per hour, right? So in that case, the Z score will be 60 minus 65 divided by 5. You will get a -1, right? Your Z score is -1. So in the case of Z score is -1, you will get a probability somewhere around 0.158, right? Somewhere at 15.8%, right? So your cumulative probability will get decreased in the case when you are leftmost of your mean, and if you are high, it will be high when you are in the rightmost of the mean. Continuous random variables, we always seen value can be take any number, right? So it can be a 1, 2, 3, or 1.1, 1.2, 1.3, so and so on, right? So it can take any number. Similarly, for the Z score also, it can take 1, 2, 3, -1, -2, -3, or maybe it can take 1.1, 1.2, 1.3, 1.345, something like that, right? So in Z score, we can have any number, 1.35, 1.2, 1.5, 1.25, 1, 2, 3, and so on, right? So it can take any number, right? So now, so finding of these probability for this decimal points, so what mathematician has done, they have calculated all the distributions probabilities for each and every random variables, which lies between -3 to +3 range of the Z score, right? So and they have put it into the table, which is called a Z table, right? So let's deep dive and understand how we can identify identify the probability from the Z tables. And understanding and reading the Z table is very important. So I'm just going to show you how, and also wanted to illustrate you how you can try to get the probability from the Z table. Now just take example of employee commute time bit less than 43.25 minutes, right? Where we have a mu equal to 35, standard deviation is 5, right? So what would be the Z score? Z score would be 43.25 minus 35 divided by 5, we get a 1.65, right? So P of Z, also we can say P of Z score value 1.65, what would be the probability, right? So actually it comes around 95.5%. so but let's understand from the Z score. So see, we have a 1.65, right? So after the decimal point where we are going to have, we have a 6 here, right? So this 0.6, we have 0.6, and we have to go till here 0.65, 0.742. So this is a positive Z score, and this is for the negative Z score. Left side is for the negative Z score and right side is for the positive Z score, right? So what we have 1.65, right? So we have to go from and identify 1.65. So 1.65 come here, and then we have 1.65, right? So after 2 decimal points, so we have to go till here, right? So 0.5, what we get are 0.9505. So we can note down this. We will get a 9.9505. Right? We can say 95.05%. Right? Similarly, if I say to you probability of 25.2 less than x less than 44.8, right? So if you see the standard deviation is, it will come minus 1.96 for the Z score, and Z is 1.95, right? You can easily calculate this, 35 minus 25 minus 35 divided by 5, it will come 1.96 minus 1.9. Similarly, so I have put it here, right? Now we have 1.96 and 1.95, right? So now we can say we can calculate it. So now we are going to calculate P of Z equal to 1.96 minus P of Z equal to minus 1.96, right? It will give you the probability for this guy, right? So Z equal to 1.96, what would be the probability? We will go here and we will see 1.96. So 1.9 here, and the 6 is 0.975, right? So you can see the down, extreme down, and the row is 0.6 columns you have to see, and the row of 1.9 you will see, and then you will get a 0.975. So 0.975, 0.9750 minus 1.96. In the minus case, you will see, you have to see here, right? 0.0250, 0.0250, right? And then you will calculate, this will comes around 0.95, which means 95%. So in the same way you can calculate you can refer this Z table. I will add this Z table in the description box, so you can download the Z table, play around with this different combinations. So it will give you the right understanding. And so because this is very important, because you cannot calculate everything by your hand, so you have to go to the Z table to refer the actual probability for these decimal points on around this Z table. Why this Z table is so much of significant, and from what are the places we can use in the application, because Z score is tremendous, and across a lot of application it has been used, and there are a lot of research paper has been published just to calculate your analysis based on this Z scores and all, right? For example, let's say if I show you the Z score of a boy who's turning 6 months, right? So 0 to 6 month journey you can easily illustrate with this Z score, right? So if you see, this is it's a week time, right? So first week, second week, third weeks, up to the 13 weeks, right? So average is this weight. So no, in a 6 month your baby should turn in the 6.2 or 6.3 kg weight, right? But some babies tends to get a higher weight, which is extreme, and some baby get a lower weight, right, which is lower index of this, so -3. So Z score, if lower the Z score, your cumulative probability would be less. If the higher the Z score, your cumulative probability would be high. If your data is naturally created, and there's no artificial entries you have added in that means your majorly of the major data sets would be lies in between 99.7% of your range, right? But there are few outliers which can go beyond your data sets, but that you can detect through this Z score, right? So Z score is very important concept. So that's it from this video. We will talk about the CLT, central limit theorem, in the next sections. So till then, bye bye.